Hello everyone, welcome back to Easy Core. In today's lecture, we are gonna study about what is a signal and what are the types of signal, and we will understand the types of signal by with examples as well. So let us start without any delay. The first type of signal, first is what is the definition of signal. So we can define signal in many ways. So uh, mathematically, we can define signal as a function of one or more independent variables. So this is a mathematical formula. So how we define a textbook definition for a signal is a quantity having some amount of information associated with it. Means if I am able to convey some information. So the what I am speaking, this is known as speech signal. So signal is an entity. It can be a physical entity which will have some information, which will have some meaningful information in it, and that will be transmitted from one place to another. You can see here it is a quantity having some amount of information. And another definition would be a signal is an indication about which amount of information is conveyed. Some amount of information is conveyed from one place to another. You can it is indication in which some amount of information is conveyed from one place to another place. So these are the different types of signals. So if you can simply uh, say for interviews you can say that signal is an indication about some amount of information, and then if you simply say this one, and you will uh, be awarded right answer as well. So let us understand signal with an example. So we have seen here that signal is a function of function of one or more independent variables. So here we have seen one or more independent variables. So these independent variables may be anything, and you may have one independent variable and one uh, dependent variable as well. So here what I'm having is I am having a speed signal where the x-axis I am having time and I am having pressure here. So here what we can write, speed signal is represented as acoustic pressure as a function of time. Here you can see in on based upon the time my pressure is changing on base on which I am having my speed signal. So let us uh, uh, go into the types of signals here. We will first study the signals based on nature of variables. So here we are having two types of signals based upon nature of variables. One is independent variable, and that is time, and dependent variable amplitude. And keep in mind, independent variable may always it will not be time. It can be another variable also, and dependent variable may also differ in some cases. So here, and independent variable we will always write in we will also represent in x-axis, and this one we will represent on y-axis. So in independent variables, we have continuous time signal and we have discrete time signal as well. And similarly, in dependent variables, that is, we in amplitude we have continuous amplitude, and we will have discrete amplitude as well. So we will learn about each one: continuous time, discrete time, continuous amplitude, and discrete amplitude as well here. So first we will study continuous time signal. So what is continuous time signal? It is represented with x of t, and this x of t is always integer, and integer and non-integer. T can be integer and as well as non-integer. So what does this continuous time signal say? The continuous time signal is the type of signal where you will have where a value is present at every instant. So if you are taking, let us take an example of take x of t. I will write it here. X of t is equal to e power minus t for t greater than or equal to 0, and 0 for t less than 0. So here I am having a continuous, we will understand by drawing this one here, continuous signal. second. Yes. And here you can see this will be my x of t, and this will be my t. So here see, for at 0 and greater than 0, I am having all the I'm having the signal for greater than 0, and for less than 0 I'm having 0. So if I'm taking for integer and non-integer values of time, I may take this value at 0 or 1 or 0.1. I can take this 1, 2, 3, and if I can, for continuous time signal, I can also take value at 0.5, 1.5, and 2.5. These are the non-integer values, and 1, 0, 1, 2, 3. These are my integer values. So every instance of for every integer and non-integer instance, I'm having my signal. So that is a continuous time signal. So what is discrete time signal? A discrete time signal is represented with x of n. So here, to differentiate between continuous time signal and discrete time signal, we are replacing x of t with x of n. So here n will only be integer, means our discrete time signal will only have amplitudes only only at specific instances, at only integer instances only. So we will understand that with an example here. So let us take here. So my this will be my x of n. This will be my. So let us understand this one here. At 0, 0, and I will take this one. This can also be 0 as well. So here also I can have value. So I will write the values here. So this will be 0, 1, 2, 3, 4, 5, and so on. -1, -2, and -3. So here in discrete time signals, I am only having the my signal at my amplitude at only in discrete times, that is only for integer values of time. Here you can observe here. So I'm having one here, and this amplitude may be continuous and discrete. That does not depend upon here. This amplitude can be continuous as well as discrete as well. So this can be 1.5, this can be 2, 2, -1, -2. So this is my discrete time signal. Only n will only be integer. Only at integer intervals I am having my values at 0.1.1, 0.1, 2.5. I am not having the signal at these non-integer values. So this is discrete time signal. Now let us understand what is a continuous amplitude signal. The continuous amplitude signal is it can be uh, written as a x of t. Here a is infinite number of amplitude, and a defines our amplitude here. So in continuous amplitude signal, we will understand with an example. Let us take a sine wave. Sorry for drawing this. Let us take this one as example, and this one here 1, here 2, 3, and 4 here. So here what I am having is, let us see at 1. Let us take this one 8, and this one will be -8. So from 1 to 3, my signal is going from 8 to -8 here, from in the interval of 1 to 3. So from 0 and 1 to 3, I am having infinite number of amplitudes. You can take we will not have only discrete time of amplitudes at if it may, the continuous amplitude signal will be available at every instance of time, whether your time is continuous or discrete, but your signal will always be continuous, it will always be available. So let us understand with discrete amplitude here what we will take. And here what, and one more thing, let us check if for x of t at I will write here x of t at t is equal to 1 is equal to 8, x of t at t is equal to minus 1 is, sorry, minus 1, t is equal to 3 is equal to minus 8. So what we can understand here, and in between these intervals, I am having infinite number of amplitude from 8 to minus 8. You can have 0, 7.9, 7.8, 0, 0.1, 0.2, 0.3, 0.4. You can see, and if I am taking continuous time, then I can take a valuables for 1.2, 1.3, 1.4. If I am taking for discrete time, then for 1, 2, for 2 it is 0, and 3 it is minus 8. So if I am taking for discrete time, then I will take only for amplitude at integer value, and for continuous time, at every instance of time, I can take the continuous amplitude signal. So now let us understand what is discrete amplitude signal. Here let us I will draw one waveform here. So let us understand this waveform. Here let it this one be 0, and for uh, this will be amplitude 1. This is 1, 2, 3, 4, and this one will be 5. Let us take here 4. So here let us see. For 0, I am having only 0. Even though if I am for continue, this can the discrete amplitude signal will be available for continuous time as well as discrete time. For continuous time, if you take for if I am taking for 0.1, 0.2, 0.3, my amplitude signal will always be 1. If I am taking at 1 and 1 to the interval between 1 and 2, it will always be 2. Similarly, for from 2 to 3, it will be 1. So if I am taking my interval at 3, 3 to 5, then this will be minus 1, and at 5 it will be, say, again come to 0. So this is a discrete amplitude signal where you have only finite number of amplitudes. Then here, right here, finite number of amplitudes. So these are the types of signals based upon the nature. In next video, we will learn about the discrete and continuous time when we are mixing two types of signals here with two types of nature variable. If we will see for continuous and continuous time signal and continuous amplitude signal, we will take a continuous time and discrete amplitude. We will take discrete time and continuous amplitude and time and discrete amplitude signal, and we will observe the difference between them. So stay tuned up to next video. If you like the content, please like and subscribe. Thank you.